Good morning, students. Now we are coming to the end of the lesson. Amines. Next, I will start with diazonium salts. Diazonium salts have the general formula R(N2)X. This nitrogen will be having a positive charge and X will be having a minus charge. This R stands for an aryl group, and this N2 with a positive charge, this stands for diazonium group, and X minus, I mean the X ion. This can be a chloride ion, a bromide ion, HSO4 minus, hydrogen sulfate ion, etc. Next comes the nomenclature. These compounds can be named by suffixing diazonium to the name of the parent hydrocarbon from which they are formed. For example, C6H5N2Cl, benzene diazonium chloride, benzene diazonium chloride, C6H5N2HSO4 minus, benzene diazonium hydrogen sulfate. This is about the nomenclature part. Next, this primary aliphatic amines, they are very unstable and they form unstable alkyl diazonium salts. Primary aromatic amines, they also forms arene diazonium salts, but they are stable for a very shorter period of time. In solution at a very low temperature of 273 to 283 Kelvin. Actually, primary aromatic amine, the stability of arene diazonium salts can be explained in terms of resonance. I have written 5 resonating structures for arene diazonium ion. Arene diazonium ion. I hope that now you are thorough with how to write resonance structure. Okay, next, methods of preparation. Benzene diazonium chloride can be prepared by treating aniline with NaNO2 and HCl. NaNO2 means sodium nitrite and HCl. Why we are using NaNO2 and HCl? Written the equation separately. NaNO2 plus HCl gives HNO2 plus NaCl. Nitrous acid is obtained here. So we are treating aniline with nitrous acid. Why we are making nitrous acid separately? Because nitrous acid is very unstable. Immediately it will decompose. So to avoid that, we are treating aniline with sodium nitrite and HCl at a temperature of 273 to 283 Kelvin. We are getting benzene diazonium chloride, sodium chloride, and water. Okay, so this is about the preparation. Now another point to be noted here is diazotization. What do you mean by the term diazotization? The conversion of a primary aromatic amine into diazonium salts, that is called diazotization. Actually, this compound is unstable. So we cannot store diazonium salts. We have to use it immediately after its preparation. Then comes to physical properties. Benzene diazonium chloride is a colorless, crystalline solid, readily soluble in water, stable in cold, but react with water when warmed. Now comes chemical reactions. Chemical reactions are very, very important. Actually, chemical reactions are classified into 2. Reactions involving displacement of nitrogen and reactions involving the retention of diazo group. So these are the two reactions of this diazonium salts. Now let's see the reactions one by one. First one, reactions involving the displacement of nitrogen. First, the replacement by X minus. X minus means halide ion, Cn minus cyanide ion, etc. Actually, we studied this reaction already, Sandmeier's reaction. So, Ar(N2X) when treated with the Cu2Cl2 in HCl, ArCl, Cu2Br2 in HBr, ArBr, CuCN plus KCN, ArCN. So these reactions will help us for conversion purposes. So write and practice. Now another reaction is called Gutterman reaction. Gutterman reaction. Ar into X minus when treated with copper powder and HCl, copper powder and HCl. That is, a chlorine or a bromine can be introduced into a benzene ring by treating a diazonium salt with the corresponding halogen acid in presence of copper powder. The reaction is named as Gutterman's reaction. Then another Ar into X Cu HBr ArBr. Okay. Then the replacement by iodide, I minus, iodide ion. Iodine can be easily introduced into the benzene ring, but when treated with potassium iodide, we are getting iodobenzene, ARI, iodobenzene. Then comes replacement by F minus, fluoride ion. When iodine diazonium chloride, when it is treated with the fluoroboric acid, HBF4, fluoroboric acid, iodinium diazonium fluoroborate is obtained, which on heating, it decomposes to arene fluoride. These reactions are very, very important, students, for the conversion purpose. Next, replacement by X. Certain mild reducing agents like a hypophosphorus acid, which is generally called as phosphinic acid or ethanol. It reduces diazonium salts actually to iodines and getting themselves oxidized to phosphorus acid and ethanol. This reaction is also important. So actually, it reduces diazonium salts to iodines, getting themselves oxidized to phosphorus acid and ethanol. So equation Ar into Cl plus H3PO2 plus H2O, we are getting ARH. Ar into Cl plus CH3CH2OH is ARH plus N2 plus CH3CHO, ethanol and HCl. Next, replacement by a hydroxyl group, OH group. So the temperature of the diazonium salt solution is allowed to rise up to 283 Kelvin. The salt is getting hydrolyzed to phenol. So reaction Ar into Cl plus H2 gives AROH plus N2 plus HCl, and the replacement by NO2 group. So benzene diazonium chloride when treated with HBF4, fluoroboric acid, it forms benzene diazonium fluoroborate, which on treatment with sodium nitrate and copper heat. We are getting nitrobenzene along with the nitrogen and NaBF4. So this is about the chemical reactions involving the displacement of nitrogen. Now the next is chemical reactions involving the retention of a diazo group. This is also very important for your examination point of view. Actually, before explaining the first reaction you have to study is coupling reaction. So before explaining this coupling reaction, I have to explain the azo product obtained how a conjugated system. You know what is a conjugated system? Having both aromatic ring joined through N bond. These compounds are colored and are used as dyes. So first we will start with the coupling reaction. Compounds are this benzene diazonium chloride, when treated with phenol. Actually, you have to write like this only. Don't do any changes. Benzene diazonium chloride, when treated with phenol, this OH in the para position, it forms para hydroxy azobenzene. This is an orange dye. Students, you should write and practice only like this to form this compound. Here, I have drawn a circle over here so that this HCl. So your writing work will be very easy. Next, when benzene diazonium chloride, when it is treated with aniline, in presence of H plus, here in presence of OH minus, here in presence of H plus, to form para amino azobenzene. Para amino azobenzene. This is an yellow dye. Okay. So this is about the chemical reactions. Now I have written one conversion which is solved in the textbook. Write that also in the classwork. How will you convert 4-nitrotoluene to 2-bromobenzoic acid? As I told you before, when a question is coming for conversion, what you have to do first? Write the formulas of the starting reactant and end product and put a question mark so that our work will be easy. Okay. So 4 nitrotoluene. When treated with the bromine, this product, bromine will be introduced in the ortho position. Then reduction with the tin and HCl. So what happens here? This NO2 is getting changed to NH2. Then diacetization reaction, NaNO2 plus HCl, 273 to 283 Kelvin diacetization happens. So NH2 is getting converted into N2Cl. The corresponding diazonium chloride is obtained. This on treatment with the H3PO2 and H2O. So we are getting, this N2Cl is removed. So we are getting 1-bromotoluene. Then this on oxidation. This particular product on oxidation with the KMnO4. We know CH3 group is changing to COH to form the product 2-bromobenzoic acid. So this is about the lesson amines. I tried my level best to explain the reactions, but I request you all write and practice well. Then one homework 13.9. So students study well, practice writing, and from today onwards I will give you conversions, how to do conversions side by side. Okay, and do the test well. What are the doubts are there? Please clear it. Thank you.